Welcome back to Physics 130. Today we're going to start Chapter 3, which is about vectors. So Chapter 3 is about vectors and coordinate systems. So in this chapter you will learn how vectors are represented and used. Okay? That's the main goal. What are vectors? How do we represent them? And then how do we use them? How do we add vectors together? How do we multiply vectors together? And so on. So let's see in more detail what's going on. So by the end of this chapter, you will be able to describe the difference between vector and scalar quantities, identify the magnitude and direction of a vector, okay? Explain the effect of multiplying a vector quantity by a scalar quantity, describe how one-dimensional vector quantities are added and subtracted. One-dimensional vector quantities, that's what we really did in the previous chapter. We just said plus and minus, left and right, because we had just one direction to move. Either you go forward or you go backward, to the right or to the left. You had no other direction. But now, in this chapter, we will start about two-dimensional motion, and it's much richer. So let's see. We need to be able to explain the geometric construction for vector addition or subtraction of vectors in a plane. It's a very useful skill, and we also need to be able to do it analytically. So that's also another thing. So I'll discuss that. So we need to be able to distinguish between a vector equation and a scalar equation. A vector equation, if you have two vectors to be equal, then each of their components have to be equal. Again, I will discuss those in lecture very soon. We will describe vectors in 2 and 3 dimensions in terms of their components using unit vectors along the axes. Unit vectors, we call them I hat, J hat, and K hat. I hat will be a vector. By hat, I mean it will look like the letter I, like this. It's a vector of length 1 in the x direction. J hat will be a vector of length 1 in the y direction, and K hat will be a vector of length 1 in the z direction. Again, we'll discuss this soon. We need to be able to distinguish between vector components, or between the vector components of a vector and the scalar components of a vector. Okay, we need to be able to how to explain how the magnitude of a vector is defined in terms of components of a vector. Okay? That's where the Pythagorean theorem comes into play. Identify the direction angle of a vector in a plane. So given the components of a vector, you need to be able to tell the direction, the angle that the vector makes with the positive x-axis or the y-axis, usually the positive x-axis. And then explain the connection between polar coordinates and Cartesian coordinates in a plane. Not so much for this point here. In later chapters, we'll emphasize it more. All right, so mainly though, we need to be able to apply the analytical methods without drawing, without graph paper, without anything. We have to be able to analytically use the vector algebra to find the resultant of vectors and to solve vector equations for n-noun vectors. And then interpret the physical situations or interpret physical situations in terms of vector expressions. Determine the scalar product of two vectors. That's called the dot product of two vectors. We will need that more specifically in chapter 9, I believe. That's where we do the work done by a force. So we need to be able to do the scalar product. There is an additional product called the vector product or the cross product. We'll discuss that in chapter 12, where we do rotational motion. That's when we discuss cross product. But I will discuss it anyways in this chapter, just so that we will have seen it. I will discuss it when we will do our worksheets. And then finally, describe how the products of vectors are used in physics.